Hello! Welcome, welcome, welcome. My name is Stefano. I'm joining you here from Science World. I'd like to start the show off today by acknowledging that we are gathered on the traditional and unceded territory here at Science World of the Coast Salish people. That's the Squamish, Musqueam, and Tsleil-Waututh. Thank you for joining us online. I am very excited to be presenting the show today. So many things to do. We've got a few viewers here started already, I can tell. And for those of you who are new to this, thanks for joining us. And for those of you who are returning for this live stream offering that we're doing, I'd like to say thanks for coming back. Now, for those of you who are new, I would like you to offer your enthusiasm, your ideas, your participation through the chat right here, somewhere on the screen digitally, wherever yours is set up. And you can enter that in right now. In fact, I'd like to encourage all of you to let me know where you are joining us from. It could be from your living room. It could be from your city. It could be from your province or your country. Anywhere you like, even if you're joining us from Mars. That would be really cool, by the way. So just want to do a real quick shout out. Of course, we've had lots of viewers joining us through all these. This is our 9th live stream, and it's a pleasure to be here with you today. Tegan and Kira have been joining us for most, if not all, of our live streams so far. I want to say thanks so much for Tegan and Kira for joining us. You've been answering great stuff in the chat, and I think that that's just fantastic. And I know that you are very, very eager participants in science, and I would encourage the rest of you to do the same, and you can do so at our resources website on our website, and that is scienceworld.ca/resources. And you can check that out anytime. In fact, we've got lots of stuff on the go here at Science World, behind the scenes and online, and you can check out all our online offerings, at Dome at Home on our page there. You can see the live streams, check all that stuff out, and participate that way. So I want you to know that we're doing our best here, and we're keeping socially distanced, which we've got some crew here, Ashley on the chat, Jeff on the camera, and which is why we're taking our proper precautions. We think safety is very important, and we believe we're right. And so we're doing that here at Science World, and we encourage you to do the same. You're doing a great job so far staying socially distant from me by staying in your home and watching this online. Great work. We have a safety zone here, so yeah, stay on the other side of that safety zone. Good job so far. Throughout the show, I'm going to be using all the proper safety equipment as necessary, including goggles, fire extinguishers, and any other safety I need. And I encourage you always safety first, and put that science in right after that. So, who here is ready for a science show today? Right, I can't hear you live. I have to read the chat. Ashley, have we had any responses on the chat from anybody who is visiting us from somewhere else, or anything they want to share with us so far?
Chapman is from New Westminster.
Chapman is from New Westminster. Welcome from New Westminster, our province's original capital, and a lovely place to boot. Well, thanks for joining us. We're going to get on with the show today very shortly here, and I would like to let you know the show is called How2Science. Now, this is a special show, because you may or may not know this. Jeff, can you zoom in here? I want a little personal moment with the audience here today. You may not know this. Maybe you do. But we get all around the province. It's really important for us to get all around the province. And one of the shows that we bring to schools around the province is called How2Science. And yes, it's for younger audiences generally, but I believe it's the cornerstone of what we do here at Science World. It's observing, predicting, and testing. And you can apply that to anything you do. And I encourage you to do that. So we're going to do that throughout the show. The show is called How2Science. I'm going to get you to observe, predict, and test. Now, I'll do the testing, I suppose. But you can do it at home if you're doing this at another day when you're watching us on the YouTube channel, where we'll have this posted afterwards. And I would encourage you, as we observe, to write those things into the chat. So if you're observing something interesting, for example, the fact that my mask is coming a little bit off of my nose, just getting used to it myself, folks. There we go. You can let me know that, or anything else you observe that I offer to you. Now, observing doesn't just happen with our eyes. Of course, we use all our senses. We use the sense of sight, taste, touch, smell, and, what did I miss? Hearing. And those are the 5 senses we're going to want to use to observe things. So if something sounds dangerous, or smells dangerous, or looks dangerous, we want to stay away, and also just take the precautions necessary. So observing is very important. I'm going to ask you to observe this very first demonstration. And if you'd like to play along with this little thing I like to do, is you could do one of these. You can put your observation goggles on. I look like an owl, I think. Hoo, 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 hoo. And you can do whatever you like, but as long as you're watching. All right, Jeff, what I'm going to do is I'm going to pour a little bit of water here into one of these cups. And you'll notice I've got a cup here. I'm going to pour some water into it. And water is heavier than air, so it drops into that cup nicely with the force of gravity. Thank you very much, gravity, for helping me out on this. And what I'm going to do here is show you that observing is so important. You may not have noticed, and it's tricky from a distance, that I had more than one cup here. I had 2 cups here. In fact, I had 3 cups here. In fact, I actually have no, just 3. I have 3 cups here. And Jeff, I'm going to get you to zoom in right here. And in all this cup management that I've been doing, you may not have noticed exactly where the water went. And there's only one way to find out, is to make a test. But before we do that, we want to predict. So I'm going to get all of you, I'm going to name these cups, cup number 1, cup number 2, and cup number 3. And I want you to type into the chat which number that you think the water is in. It's going to be harder. I believe they went off screen for a second, and I was talking, and you're probably eating your snack right now. So it's really important for me to have you help me with your prediction. Put 1, 2, or 3 in the chat. Now, when you have a prediction, that's great, and the last step is to test it out. Now, when you want to make a prediction, you can scrub your chin like this, or you can just kind of ponder a little bit, or you can just say it. And the testing part is the funnest part. I like to do test it out, and I like to do that and yell it out, and it's always very enthusiastic from my end. So you're welcome to do that from home, so your neighbors know you're doing science. All right, so I'm going to pour out one of these cups and pour it into one of the other cups. This is cup number 3, if you're paying attention. And cup number 3, I'm going to pour it out. That's my test. And I could do lots of different ways of testing it. I could look in with my eyes, and you wouldn't see it. I could weigh it and see if there's water inside, but you wouldn't necessarily see that either. I'm just going to pour it out, nice and simple like I did into the cups originally. I'm going to pour that out into this container right here that it came from. Here we are. And if you predicted number 3, by the way, did you have predictions in there, Ashley? Any? You got a couple number 3. This is for you, number 3, folks. You believe. You think the water's in here. Let's find out if it's in here. You ready? Number 3. Here we go. Make a prediction of 3. And good prediction, but not in there. All right. Now, that's good news, because not knowing something is just as important as knowing something, because you know that at least it's not in that one. Cup number, should I do cup number 1 or 2? What do you choose? I'm going to go number 2. It's 1. It's the closest. And just because that's heavy, I'm just going to pour it into this one here. It's simpler. I'm going to pour it, and if it's in there, cup number 1 votes are going to get a nice round of applause from me. Number 1 votes. Oh, you were right. Cup number 1 votes. Very nicely done. Cup number 1, you did a very good job. And of course, because I want to test everything in my process here, and there was water, and we poured it into here, I just want to make sure that it's still in there. So I'm just going to put it back from cup number 2 back into the container. Here we go. Wait a minute. Wait, we just did it together. We observed, we predicted, we tested. We had it in here, no, we had it in here, went in there, and I got a little lost. I'm going to need your help, everyone in the chat. Where did my water go? You saw me pour it from cup number 1 into cup number 2. So I'm just curious where it went. We know things about water. We know that it changes state from solid to liquid to gas, evaporates. So maybe it evaporated. It is pretty hot under these lights, but it doesn't evaporate that fast. It's not that hot here at center stage. Any predictions or ideas of what might have happened to my water there, Ashley, on the chat?
People don't know what cup it's in.
People don't know what cup it's in, so it's tested again. So it's not in here, not in here, seemingly not in here either, but that keyword seemingly. Now, I did a little trick. Jeff, let's zoom back out a second. I'm just going to go upstairs here. So we did pour it into this. We did it together. We tested it out. It was in there. We won that battle. But it's still in here. I'm telling you, it's true. What happened was there was something else in that cup that you may not have noticed off the top of the show because I put it in there prior to starting. And I put something called sodium polyacrylate. It's also called slush powder or lightning gel, and it actually absorbs liquids. So when we did our experiment, we did everything right. We figured it out. We observed, we predicted, we tested, but there was another variable. There was something different, called it a variable, that impacted our water. There was a chemical reaction where the water basically turned into a gel. Now, interestingly enough, you've all done this, believe it or not. You've all done, well, most of you have probably done a version of this. Let's put it that way. And you've done that with this piece of equipment right here. This piece of equipment right here. This is a diaper, size newborn. It's a good starter diaper. I used this myself when I was a child. Not this particular one, of course. And so this actually is where the science of something like this can be applied to an everyday use, and maybe sometimes more than once a day. So diapers are the science. There's science even in diapers is what I wanted to say. And here's some of that slush powder. I'm going to put it back in here and get on with my show. I hope you're having a good time so far. You're observing, you're predicting, and then we're testing together. Now, you know, it was hard to see the water inside those cups because they were not transparent. So maybe I'll just get this jar here. Jars are transparent. You can see me through there. Everybody, can you see? Can you see my Science World sign there? I'm going to pour some water into this one here. I'm going to do another fun test with you. So you're observing. You're observing that I'm pouring water in here just like before. You may not trust what's going on here with me today so far based on what I've been doing, but I'm going to show you a really neat trick. You can do this one at home. You can check out our resources page for some links on how to find out how to do something like this. You're just going to get a card, a plastic covered card or a lid of some kind. You're just going to put it on top like that. And then you're going to flip it upside down like that. And what's really, really interesting, I'm going to need Jeff to get right in close so he sees what's happening. And we're going to make another prediction. So Stefano right now, I am holding the lid on top of the cup that is full of water. And the air is actually inside here, is pushing down, and there's air around it pushing on it. And there's also water inside that wants to come down because of gravity, as we discussed. What's going to be really interesting is I'm going to remove this lid. But I'm going to keep it. Now I want you to make a prediction based on what you think and what you know. Prediction about what's going to happen once you've observed me removing this lid. So one of the things I predict is that I could get soaking wet and splash all over me. But that's hopefully not going to happen. But it's okay if it does. I'm not made of sugar. Here we go. I'm going to remove it gently. Remove it gently. Oh, a little bit of water came down. And the water is actually staying. I don't know if you can see. I'll put it behind here. It's actually staying inside that cup upside down. It's defying gravity, in other words. Now you saw me pour it in, and this is where science kind of comes in. You observe, you predict, and you test to find out what's going on sometimes. And you have to go back to the beginning and figure it out. Now, what's actually happening here is there's another variable at play. I actually put a little mesh. I'll show you in a second. I put a little mesh in between the lid, and you can't see that very well, but in between the lid and the pouring area. So the water went through the lid, but it's not coming out still. So it did go this way, but it's not coming this way. Now I want you to observe very carefully here as I give it a bit of a tap. And you're seeing the water is getting out. Now water is naturally sticky. The molecules stick together. It's a very unique property of water. It's very cool, and it holds together. It's like too many molecules are stuck in an elevator, and all the molecules want to get out at the same time, but they're stuck at the door. So when I give it a tap, some of them just go boop, right through the front, and they get out. But the rest of them are getting stuck in between those little fibers, those little squares of the mesh. Now, if I tip it sideways, air pressure and gravity will kick in and pour it all out nicely. But what's really cool about this one is I love to show people, I want you to look more carefully. This one's going to be more observing, all right? This one's going to be more observational. I'm going to pour more water in. More. But this time, instead of watching the water coming down, I want you to watch the water going up. So the observing here, my hand is there. You can see that there. All right, I'm going to take this away. And I want you to watch, when the water goes down this way, it's making space for more air to fill that space. And the air out here, of course, wants to go in there. So here we go. I want you to look for the air coming up. See if you see it. You see those bubbles of air coming upward? It's just like when you go to the water cooler and have some mundane conversation with your coworkers, and then you see glug, 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 glug. The air is coming up. It's filling that space because the air here realizes there's a space missing here, and it's somewhere it can go, and it pushes through, and there it is. And it's making it rain, making it rain. Pour it out. All right, that's one you can do at home. I encourage you if you want to try that out. It's not, you don't need a jar. You can do a jar, you can do a cup. As long as you get a piece of mesh like this. I'll show you this way. My neighbor was luckily wanting more mosquitoes into his apartment, so he said, you can go ahead and take my screen door apart. So I did that, took a square. And all you have to do is take that mesh, put it on top of a cup, put an elastic band around it, and you can try this. I recommend trying this at bath time or outside in the summertime. So if you do get some splashes around, it's totally fine. All right, zoom back out. We got some more science. Is anything from the audience, from our live audience, that I should know about Ashley? I feel like they're watching, they're observing, they're predicting, and they're doing some good stuff from home. If you have somewhere you're watching from, if you have a school you want me to do a shout out for, if you have some science that you'd like to do and you want me to know about it and tell everybody that's watching about it, let me know. I'll do it. It's good that way. Tegan and Kira, we did a little shout out to you earlier. I'm going to do it again. Thanks for joining us. I was wondering if you'd show up, and I'm really glad you did. Thank you. It's great to have super fans out there, and I really look forward to you being the Science World facilitators of the future. You could do this job, totally. Just you got all the practice, you learn in the shows, so thank you. All right, so we had some air moving in and around that jar. I've got a larger jar here with me right now, and you may have noticed this demonstration from the air show. I'm pretty sure Tegan and Kira probably noticed this, but we had this demonstration when our good friend Rachel did the air show. And so she did a demo where she put a balloon inside, and we watched what happened when the air went and came out and in of this jar. So we're going to do that today again, because we're going to observe, predict, and test. We're just going to observe what's happening, we're making a prediction, and then we're going to test it out. So we need a balloon. There we go, balloon. It's hard to inflate a balloon with mask on, so I'm just going to, this balloon. This one will do. There we go. Always be prepared. So I've got a balloon, and I'm going to put it inside this like that. So you can see the balloon's inside. Now there's air in the balloon, there's air outside of the balloon, and there's air in the room right now. Delicious, delicious air. So I want you all to make a prediction. You have an observation of my balloon. You can see that it fits. It's yellow. But I want you to make a prediction as to what might happen. If you know this from the air show, you should just write it right away. What might happen when I remove the air from around the balloon? Now, the fun thing here is that I'm using a device called a vacuum pump. You may know what a vacuum cleaner is. What's neat about a vacuum cleaner is that it doesn't actually suck up the dirt. It actually, air just pushes. I mean, yes, there's, you can use that word, sure, but air doesn't suck, it pushes. In fact, when I turn this on, air will push out this way, creating a space in this tube, and then dust that gets in the way would get picked up and go through, and that's how vacuum cleaners work. They actually work with air pushing. The fan pushes away. So I'm going to do the same thing. I'm going to create a vacuum, which is a lack of air. Space is a vacuum. So I'm going to create a space-like environment in this container. And I'm going to remove the air. Any predictions about what's going to happen to our lovely yellow balloon? Who's that? Who wants to say hi? Hume Park. Hey, Hume Park. Nice to see you. It's nice. Homelanders, that was the name of the team? I mean, Home Learners. Home Learner. We're all learning from home. This is fantastic. You got something to teach us. Well, that's fantastic. You keep learning. It's summer and you're still doing it. Amazing. Great guess. Popping the balloon is an excellent prediction. We observe, we predict, we test. The prediction of popping balloon makes sense because we know balloons pop all the time when they have too much air or something changes around them because of that rubber can burst. Let's test it out. Ready? Let's test it out. I'm just waiting for you to say it too. Okay, we're good. All right. Here we go. I'm going to turn on the vacuum pump. It's going to push air out. It's going to create a vacuum. It's going to remove the air around my balloon and make a prediction. If you watch the air show, bit of a repeat here, but I hope we can make it better for you. Here we go. Ready? 5, 4, 3, 2, 1. Blast off. All right, so our balloon is getting bigger. Look at that. Look at that balloon there. Getting big. It's getting so big. All right, I'm just going to turn that off now. Well, it's reached maximum capacity, and it didn't pop. We must use some pretty high-quality balloons here at Science World. Balloons are actually very stretchy. That's one of their properties, the elasticity. So it didn't actually pop, but that was a great prediction. It sometimes does, just so you know. It expanded as far as it could into the chamber because the air around it was removed. Therefore, it gave space for that air inside the balloon to push and create this odd-shaped balloon. Now, what's interesting is that balloon is the normal shape that we knew it in everyday environment. But if you went into space, it would expand in space and eventually pop because there's no air to push down on it in space. Now, what's going to happen when I put the air from the room back inside the chamber? Let's find out. When I remove this, you can make a prediction in the chat, but I'm just going to go ahead and do it. I don't mind you doing your predictions because then we can read up and find out what awesome suggestions you had. It could pop, Nothing could happen. We'd turn into a unicorn. We'd get 3 wishes. All these things are great. Here we go. 5, 4, 3, 2, 1. Air back in the chamber. Balloon back to normal size. Fun, fun, fun for the whole family. There we go. Now, you can't tell this at home, but remember I said about observing? You can't feel this, but if I put it up against my face, I'm feeling that this balloon is very warm, warmer than it was before. The molecules were moving back and forth in large, expanding and contracting, and so some heat was generated, and so it's actually warmed up my balloon. So in that observing, you might be like, huh, I wonder why that is, and I just told you. So this balloon, save it for later. I'm going to put something else in this chamber. We mentioned variables before, and variables are when you have something different, so I'm going to put a different thing into this chamber. And it's up to you now to hope, to guess, to predict, and you can be right, you can be wrong, you can be halfway, what's going to happen. What I'm going to do is I'm going to put 2 little cups with food coloring inside. It's hard to see the food coloring, so I'm actually going to put some shaving cream. And there you go. And then I'm going to put some more shaving cream. And you can either choose to root for one of my 2 colors. It's either yellow or red. So team red and team yellow. Can you see those colors there? There you go. How's that? Team red, team yellow. You can decide what color you want to root for. Put a little bit more, try to fill it right up. Now shaving cream is, of course, made of shaving and cream. Well, the word is anyway. And I'm going to put it right here upside down so you can see them nicely. There they are. Now, we're going to make a prediction. You're going to make a prediction as to what might happen here. I'm going to remove the air from around the little cups with shaving cream in them. We're going to see what happens when we test it out. Here we go. All right, make sure that seal is nice and tight. All right, ready for this, folks? Team red, team yellow. Make a prediction who you're voting for. There we go. Make sure it's nice and tight here. Here we go. All right, turn it on with my vacuum chamber. Hi, vacuum chamber. How are you today? I'm very good. I like to push air all the time. Me too. I'm a big fan of air. All right, we're going to find out what happens when we remove the air from around it. Oh, my goodness. They're growing. They're growing tiny little creatures made of shaving cream. Oh, they're getting bigger. They're getting taller. Oh, they grow up so fast, don't they? Look at that. I remember when yellow was just a small fluff full of shaving cream. Now it's growing up. And red, oh my, look at that. So much learning, so much growing to do. So it looks like sundaes, upside down ice cream sundaes right now. But what it is shaving cream that is just expanding, much like our balloon did. Now what's going to be interesting here, there's my switch, there. What's going to be interesting here is when we removed the air from the chamber, the balloon got bigger. And if that was your prediction that these would get bigger, that's great. But it's a bit of a different variable we put in here. So it was good to just test it out. And what we have here is the expansion of the air inside the soap, which is what makes shaving cream fluffy. It expanded, it got larger. Now the balloon went back to normal size. So my prediction is that the cups will just go back down to size. Everything will be nice and neat and tidy, and everybody will be happy. 3, 2, 1. Like I said, neat and tidy. Ladies and gentlemen, modern art. All right, so you may have predicted that, you may have not, but hopefully you've enjoyed watching this part so far. I've got some more neat stuff that air can do and what we can do with science and all the equipment we have here around us. Let's see how we're doing for time. Yeah, I can sneak another demo in. I'll do this a fast one, all right? This is a fast one. You're going to watch it happen very quickly. I'm going to take all the necessary precautions, including I'm going to need my goggles for this one because, of course, I'm going to use fire. I want you to know that I'm a trained adult. I've got my fire extinguisher here in case I had any issues. And that's the bell reminding me also to tell you to never play with fire or just doing a controlled experiment. And we're going to do this right now for you before your very eyes online. So we saw how powerful air was pushing that balloon into shape. We're going to get another demo where we're going to see the power of air. Air actually pushes at 14.7 psi. 14.7 psi is a measurement, pounds per square inch, of how we get, how much air pushes at sea level. So what I'm going to do is I'm going to try to get this balloon into this bottle. And if you want to just say the answer here, what is currently inside this bottle? Just put that in the chat, please, and thank you. I'm going to need to know that before I get on with this. Observe the bottle and predict what you think is inside the bottle. So what I'm going to do is I'm going to put this balloon inside this bottle. That's all I got to do. Got my goggles on in case there's some glass shattering. It's a glass bottle. Here we go. If they actually just pipe up if there's anybody has a prediction of what's in here. I'm just going to keep going here. All right. Just going to just put it in. This is a 1 liter bottle, and this is smaller than 1 liter, so this should fit. I'm just going to. Anybody, what's in the bottle? Is there a problem here? Air is inside the bottle. You are all smart, and I appreciate you piping up with that answer. Air is inside the bottle. So I need to empty the bottle before I put the balloon in because it's full of air. Here we go. I'm just going to pour out all the air. It's not pouring out. And the reason it's not pouring out is because air pushes, and no matter how much I pour out, air will push back harder. 14.7 psi. So what if I did it upside down? Nothing. Okay, so what I need to do is I need to remove the air from inside the chamber, which is my bottle this time. Well, how I'm going to do that is by heating up the air. Air molecules rise when they're heated. I'm going to heat them up with a piece of paper that I will ignite, which is why I've got my handy-dandy fire extinguisher here, but I won't need it. So far, running a perfect record of not having accidents around fire because of my training and, of course, learning about how to use things safely. Here we go. I'm going to warm up this air with this paper. Just going to give my balloon a little bath here. It will help reduce the friction. Friction is another good science word. When you have the balloon trying to get inside, it's rubbing against, the rubber is rubbing against the lip, and so it's creating friction. If I wet it, it creates less friction. That should help me. All right. I want best odds here. We're going to look really carefully at this because this is where the action is going to be, right here. Not here. This is where the reaction. This is the action. This is the reaction, just so you know what's going to happen. All right. This is going to go in. Test it. Yep, not good. Better if I do this way. Yep, there we go. Tested it. Observing that I'm using my lighter. Barbecue season is upon us. Here we go. I've got fire. Fire triangle is active and doing great. Put this inside. Whoop. And just at the right moment, I'm just going to place this gently on top. Action. Reaction. Ah, did it! Amazing. Ladies and gentlemen, air pushed that in for me. You see how hard I was working? I'm not even half as good as air. I'm at like 7.2 psi. I mean, really. All right, so great. I've got a bottle with a balloon in it and some smoke. This is always the problem at Science World. You have all these bottles with balloons in them, and nobody knows how to get them out. But if I know one thing, I know that air pushes, so I'm going to get something here. An air superhighway, also known as a straw. I put it in there, and actually just get my balloon flipped around so I can give me. Turn around. All right, there. See, okay, just put it. It's not. Yes, because the air is here, it's blocked, just like in that cup one we did earlier. And here we go. Now there's an air superhighway going back and forth, and whoop, there it is. There's my straw. There's my mess. A little bath for the balloon. Bath time for a balloon. Hi, Ivan. And everybody is happy because our balloon is clean and our science is working. All right, goggles off, ready for my last demo. Let's see what else I have here on deck. I was going to do a rocket for you folks, but I don't know if you guys want to see a rocket. Does anybody want to see a rocket? Oh, yeah, you're this way. Okay, hi. I was going to do a rocket. So I'll give you a chance to vote whether rocket or no rocket for the last demo. In the meantime, I do want to actually talk to you directly and ask you something. Are you having fun? Good. We're having fun here. There's lots of people working behind the scenes here at Science World, and I'm not the only one, of course. We're doing lots of great work. We're hoping to get stuff online to you and hopefully get to see you in person soon as well. And when we do, we'll take the proper safety precautions. Just so you know, the loss of our main revenue source has been a bit of a crisis for us here at Science World, given that we are a charitable organization and that is our main revenue stream. If you're able to, and no pressure, but if you are, we would definitely appreciate you to donate whatever you can. You can do so on some links below or on our website. You just go scienceworld.ca, and there's a link where you can click to donate. Now, if you do that, that would help us out a lot because it will help us ignite wonder and empower dreams today and tomorrow. Because, of course, we want to be here for a long time, and we hope you join us for a long time. That said, I'm assuming the rocket, no rocket poll probably went to no rocket. No rocket, is that correct? Nobody wants a rocket?
Everybody wants a rocket.
I always predict that the wrong way, always. Okay, so you guys want a rocket. Great, we'll do a rocket. Now the rocket we're dealing with today is going to be similar with some of the materials that we're working with today. And we're going to observe, predict, and test something very, very cool. So here's our rocket, ladies and gentlemen. This very fancy Science World special 25-cent deposit bottle rocket. There it is. Look at that. Amazing. Ooh, I can hear the oohs and ahs from all over the province and world. You may say, Stefano, this is not a rocket. This is an empty bottle. I will say, no, it is not an empty bottle. It is a bottle full of air and potential. Now, what we're going to do is we're going to add more air. Now, this is a 2-liter bottle of air, so we're going to add more air to the 2 liters. When I add more than air than 2 liters, it will become pressurized. It will have more pressure. The air will be pushing tight together. And if it's pushing tight together, it will want to leave because it will want to leave and join this pressure here. Air always moves from high pressure to low pressure. And in this case, very high pressure to high pressure, and then lower pressure. If there's a breeze, it'll join that breeze. Now, we're going to increase the pressure, and by doing so, you'll notice 2 things. You have an action, you have an equal and opposite reaction. Unlike my reaction earlier, this is the science version. So with every action, there's an equal and opposite reaction. Now what that means is that if the bottle is going to push the air this way, the bottle itself will push the other way. So what I'm going to do is I'm going to increase the pressure, I'm going to plug it, and I'm going to release it on the count, and you will help me count down, and then it will release and fly brilliantly through Science World, getting stuck somewhere up in the rafters, never to be seen and returned for deposit again. I'm kidding, we return them always, because 25 cents and 25 cents is 25 cents. All right, there we go. So I'm going to make some room for my landing pad over here. Fire extinguisher safely put away. Bottle rocket safely in place. Jeff, get a nice zoom in here. I want everybody to really see what they're doing here. All right, this beautiful device is a bottle rocket launcher. I will put the bottle on here. It has 2 liters of air currently, locked down. Bike pump in place. When I add more pumps, think about how many pumps you want, by the way. Just put that in the chat. I'm thinking maybe something like 1, 2, or 3. You can put those numbers down. I'm going to add air. It's going to go into the bottle. I will release. It will fly through with an action-reaction, and we'll all cheer and be happy. And then that's going to be the end of the show. So hopefully that works. If you have any other shows about science or any other shows, questions about science or anything else you've seen in this live stream, other live streams, just general questions, think of them now, type them in now. After the show's done, I'm going to come join you, we'll continue joining you, and we're going to have a little bit of a Q&A session, and I'll do my best to answer them. So, Ashley, you had your arm up.
We have a lot of people who want 10 pumps.
10 pumps. You're really testing my, okay, I'll get my goggles, hang on. All right, zoom out there, Jeff. Tell you what, I like to observe, predict, and test. So let's try, the least number of pumps is 1. We'll work our way up to 10, how's that? Okay, so 1 pump. I've got the 10 is a great suggestion, though. I like it. I'm going to stick with it. 1. And then we'll release. 3, 2, 1. The pump is locking this noise. Hang on. 1. Right, come on, buddy. So 1 is not enough. We've learned that. We tested it, and 1 is not enough. Magic number is 3. I'm going to try 3, see if that makes it any better. 1, 2, 3. Blast off! Maybe not what we wanted. It worked, but it didn't work awesome. So I will go to your suggestion of 10 and see what we do. We may have to retrieve this. It's on you guys. You're going to help me out. All right, 10 pumps of air. 1, 2, wait, let's do it backwards. 9, 10, 9, 8, 7, count with me. 6, I can hear you. 5, 4, 3, 2, 1. Blast off! The bottle has landed. That was spectacular. I could not have asked for more, but guess what? I'm going to do more. Okay, so we saw 1 didn't work, 3 was kind of lame, 10 was awesome. I'm going to go back, because observing, predicting, and testing means we do it over and over, and we try new things. We learn something from the whole data set. So I'm going to do 3 pumps, but I'm going to add a variable. The variable I'm going to add is some of that lovely water we were using earlier. And so I'm going to pour a little bit of water in there. Now, here's the deal. I could tell you beforehand, or you could tell me in the chat. I think that's a better way to do it. Adding water, a little more, will probably change something, because there's a new variable in the equation here. So we're going to go 3 pumps, which we saw was lame. 10 was awesome. We're going to try to match 10, but with 3 and water. Anybody in the chat want to chime in on what they think's going on here? Don't worry, I'll let you know.
One person says the moral of the story is don't be afraid to give answers beyond multiple choice. Because you went for 10.
What a great, who said that?
Keith.
Keith? Keith? Let me zoom in here. Keith, I just want to say thank you for saying that. Never be afraid to give answers more than multiple choice. You guys are right. There are so many answers to things. That's the lovely thing about science. It's not all pre-prescribed. For thousands and thousands of years, we thought one thing, then we learned something new, and then we went with that. And then we're going to learn new stuff. We're learning every day. You are the folks that are going to help us. Thank you. Keith, keep on sciencing. You ready for this? All right. I'm going to do 3 pumps. I've added water. I'm guessing this is not going to end well for me, but I'm good. I've got staff and people to help me clean up if it makes a mess. All right. I'll explain the science in a minute. Don't worry. All right. We do 3 pumps, so count backwards. Count with me. 3, 2, I'm observing the water. 1. It's gone. It's in Eureka Gallery somewhere. It's far away. Where did it go? Did you see it there, Jeff? Anywhere? No? Well, it went very far, just like 10. Yes! So 10 pumps of air, or 3 pumps of air with water, equals very similar awesomeness. Don't quote me on that math. But that's what happened was, well, I need a, all right, I'll use this as a model, because I can't find that bottle. What happened there was that there was less space. So when we put 3 pumps, the first time it was filling the full 2 liters. And the second time there was less space, so it was actually higher pressure. And also, and more importantly, the action-reaction factor that we talked about earlier, more action this way, more reaction this way. So it's heavier and harder. It's more force to push water out of the way than air. So when that air pushed, it worked harder. It pushed harder to get the water out, which means it pushed that way more, which means the bottle is going to push that way more. So every action has an equal and opposite reaction, and we saw it in action right there. There's my science show, How to Science, and the question is, how do you science? Do you have any question for us? I'm going to wrap this show up with some Q&A, if there's any, and if there isn't, I would like to encourage you to find questions, ask them, try to answer them yourselves. You have parents, you have teachers, you have mentors all around you, and you can come and ask us when it's time, and we'll do our best as well. Check out our resources online, scienceworld.ca/resources. And of course, Dome at Home's got great stuff that you can test out. So we encourage you to do that too. Ashley, is there any burning questions that I can answer today?
Carol wants to know if the straw trick works both ways.
Ha 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 ha. Carol wants to know if the straw trick works both ways. Carol, only one way to find that out is to test it. So here's what you do. You get a straw. And you get a balloon, you fill it with water, and you get some kind of solid bottle. A glass milk bottle is good. And you test it out in like this. You like that? And you say, now I can do it for you right now, or I can put that as homework. So Carol, you know what you got to do. You got to test it out. Any other questions?
Keith wants to know if the vacuum is turned on again, will we get orange?
Keith wants to know if the vacuum... Keith? Oh man, you guys are the best. Keith wants to know if the vacuum is turned on again, will we get orange? Well, my prediction is this. If I turn the vacuum on, it'll remove the air, and something will happen inside to this goo that we've created. So let's do it. You know, usually I just go and clean it. This is the first time I actually bothered to do this. So let's find out if we get orange. 3, 2, 1. What's happening right now is that the remaining slightly fluffy shaving cream is getting big again. but they're not mixing colors. I'm pretty sure the only way to get orange is to add a liquid and make them be able to get together. Still not orange, no. But great. Yeah, as you know, of course, Keith is alluding to, if you mix colors, you get new colors, and you can do that with Play-Doh, with food coloring, with all kinds of different ways, and keep searching through that answer. Anything else?
Kate wants to know, how did you get so good at your job?
Kate wants to know, how did I get so good at my job? Well, that's a plant, obviously. No, I don't know Kate, but Kate, that's very kind. Thank you for saying that. Well, I'll tell you something, Kate. I don't necessarily come originally from a science background, actually. The fun thing about me as Stefano is that I did a lot of performing arts and creative studies, and science really scared me. And what happens there is that I got a job at Science World helping to facilitate science like this. I mean, I was doing it around the province in schools and enjoying that. And that was 10 years ago. And slowly but surely, with mentors around me, they taught me how to do the stuff. They taught me the science that I may not have connected to how I knew it every day. And I really loved it. And I felt that I could do it too. So after 10 years, I guess I'm getting pretty good at my job. And I really appreciate you saying that. But the reality is, it takes time to get good at anything, and it takes practice. So I encourage you all to do that too. Thank you. I'm going to leave that as my last comment because I'm about to cry. Thank you so much for watching. I encourage you to check out all the other 8 live streams on our YouTube page and Facebook page. And keep doing science, and we look forward to seeing you in your faces soon.